Hello everyone, welcome to the SQRT channel. In this video, we are going to take a problem from GRE math test. In this problem, we have a function. The function is e to the power of t squared. We are going to take integral of this function. We are going to have the integral of e to the power of t squared dt from the lower bound that we have, which is x cubed, to the upper bound that we have, which is x to the power of 4. We are going to take derivative of this integral. As I said, this problem came from GRE, so it was a multiple choice problem. However, for the purpose of this video, we remove the choices to focus on the problem for now. Also note that the problem is a timed exam, so you need to do it fast. Before moving forward to talk about the solution, make sure that you pause the video to think about this problem. Meanwhile, please consider subscribing to this channel and we will see you in 15 seconds. To solve this problem, we are going to use the Leibniz integral rule. Let's review it first. Let's assume that we have a function f of x and t, and we are going to take the integral of this function with respect to t from a lower bound that we have ax to the upper bound that we have bx. This is the integral that we have. Now, if we want to find the derivative of this integral with respect to x, the Leibniz integral rule states that we can simplify it and write it as three components. Let's review the three components that we have here. It's basically very easy. So we are going to take the derivative of the upper bound of this integral with respect to x. We are going to take the derivative of the lower bound of this integral with respect to x. And finally, we are going to take the derivative of what we have inside this integral with respect to x. Now, focusing on the first component, when we get the derivative of the upper bound, we need to multiply that by the function in that upper bound. Same thing happens if we take the derivative of the lower bound. We need to multiply that by the function in the lower bound. And finally, note to the plus and minus signs that we have here. We have f of x and b of x times the derivative of b of x in dx. That's positive. We're going to use the same approach but for the lower bound, which is a of x, and that's going to be negative. And finally, when we move the derivative inside this integral, we are going to have positive for that. Based on these, we are going to solve the problem in a bit. Now let's solve the problem. The first thing that we are going to do is to understand what we have for f of x and t. Basically, what we have here is e to the power of t squared, and it doesn't have anything related to the x here. So that's good. So we are not going to have anything for the derivative of f of x and t with respect to x here. So the third component here is going to be 0. Now let's focus on the first component, which is the function in the upper bound. We are going to have the function in the upper bound, which is e to the power of t squared, and we are going to replace t with x to the power of 4, and then we need to take the derivative of the upper bound with respect to x, and upper bound here is x to the power of 4. So we are going to take the derivative of that, and then we need to multiply these two together. So the first component is going to be e to the power of x to the power of 4 to the power of 2 times the derivative of x to the power of 4 with respect to x. Now let's move on and focus on the second component. The second component is going to be similar to what we've discussed for the first component. It's going to be the function itself in the lower bound. So we need to calculate e to the power of t squared in x cubed, which is e to the power of x cubed to the power of 2. And then we need to take the derivative of this lower bound with respect to x. It's going to be the derivative of x to the power of 3 with respect to x. Now if we simplify everything, we are going to end up with e to the power of x to the power of 8 times 4 times x to the power of 3. Remember, the derivative of x4 is going to be 4 x to the power of 3. Now if we move on with the second component, it's going to be e to the power of x to the power of 6 times 3 times x squared. And 3 times x squared is basically the derivative of x to the power of 3 with respect to x. So that's our final answer, and it was basically one of the choices that we had in the problem in a multiple choice exam. Thanks for watching the video. If you would like to see more puzzles, math involved activities, and problems from different math competitions and olympiads, please subscribe to this channel. This is the SQRT channel. I hope to see you in the next video.